Hello, my friends. So today I want to speak about one of the most underestimated and one of the least used features in Zbrush and Redshift, which is vector displacement. Let's see at this animation, let's see at this model. How do you think, what's the poly count here and how many UDIMs are here? And it will be a surprise for you, but this is one UDIM 8K with a model that is 79K. I have a lot of friends in VFX and CGI, especially those who work with games and who work with movies. And for those people, the standard is like 3-5 UDIMs per character. It's the standard, it's what usually used. Well, here, using the vector displacement technology, I was able to create this model with all those fine details saved and baked into the vector displacement without the need to use the UDIMs at all. It's just one patch, 8K, and the poly count is very low. So the main difference between the normal displacement and the vector displacement is that usual displacement, not the normal BAM, I mean the usual displacement map is it extrudes the details on top of the model based on the normal direction of a certain polygon. So if this polygon is located like this, displacement will extrude right here, right? So while the vector displacement is not binded to this technology, it uses different algorithms to calculate how the shapes and the details have to be extruded from the model. And it allows to make so-called locks in the geometry. So I have the background as a sculptor. I have 6 years of sculpture education. And when I was in the university and we were creating the molds of our sculptures, our teachers always told us, avoid the locks as much as possible. So the locks in sculpture is the places where the shapes kind of go this way. So when you are making the mold, and this mold is hard, right? It's plastic mold, and you want to take it off, and this lock doesn't allow to come it off, right? So you have to make all shapes as straight as possible to avoid those locks. The same thing we have with the vector displacement technology. Vector displacement allows those locks to happen, and this is a huge difference between the regular displacement. So again, this model here is 79K, 1 UDIM, 8K size. It's incredible what I was able to achieve here with using this technology. So I'll show you the workflow from Zbrush to Redshift, how to set up these maps, what are the obstacles, what are the difficulties, the best ways to move forward, and how to solve certain issues that you may have during your work. So let's start. So just to show you how powerful this technology is and how underestimated this technology is. So this is how the low poly model look like. As you can see, it's super low poly. There is literally no details, no spikes here, nothing. And this is the model, which is 82 million polygons that I was able to bake into one UDIM, saving all those fine details. This is the render straight from Redshift, where you can see this low poly model and all those details baked into this model using vector displacement. As you can see, each little detail is saved here. Nothing lost in the transition. So now let me show you how to use this technology. So let's go to Zbrush. Here we have our model. This model is like 80 mil, right? And before we start, we want to make some initial settings for the export. So let's go to the lowest subdivision level, so it's easier for us to operate. And let's go to preferences, and first let's go to the model export. So here you keep everything as it is right now. You can put smooth normals, so when the model is exported, it's not rigid, it's not edgy, but it's all smooth. Or you can apply the same settings in your 3D software package. It depends on your preference. I prefer to keep it here. Also, if you're using Maya as your main 3D software, I recommend turning this off because if you leave it on, when you import the OBJ into Maya, it will give you like all polygroups separated, and you'll have to, to combine them in Maya, which is a lot of time that you don't really want to waste. So I keep this off if we are working with Maya. Yeah, now once this is done, let's go to Vector Displacement Map settings, and here you want this option here to be on, and also in this field you want to put 47, and in this field you want to put 25. I will speak later why this is, and usually this number is the same for all packages, but depending on the package that you prefer to use, like Blender, Cinema 4D, Maya, or some other, this number here may be different, and I'll speak about this later. But if you're using something very common like Maya or Cinema 4D, just keep it 25 for now. And now let's go to the Vector Displacement Map settings. Here we want this, and this to be on, and also you want to go here and put obviously the map size of your preference. I put 8K because I don't want to have to deal with any UDIMs with my work here with my Dragon. There is no point using UDIMs. One more thing, important thing about vector displacement is that in the settings you are able to set up some kind of LOD that will adjust the density of polygons and tessellation depending how far is the object from the camera. So usually UDIMs used in movies and like high fidelity videos to create this LOD effect, while let's say it's a Godzilla movie and it's super heavy in polygons, and the artists have to create those LODs for, let's say, very close-up face, right? While the tail is out of focus and obviously it doesn't need to have all those load in details. That's another reason why people use UDIMs. But here with vector displacement, you don't need to worry about that, because in your settings in your 3D package software, Redshift will allow you to adjust this auto tessellation depending on the camera distance. So settings, and it's important also to mention that some people recommend using Multimaps Exporter plugin to generate the vector displacement map, while me personally, when I'm trying to use this plugin, something is not working. Like I have errors, I have different troubles when setting up the model when I'm using this plugin. So I just prefer to use my hands and old school methods of exporting the maps and exporting the model just by hands, by exporting all things separately. So it's up to you. You can try to use that plugin, but I prefer use like my hands, as in good old days. And I believe we're all good to go. So all we need to do is just set up go here, export. We set up the model export settings. We set up the vector displacement map settings, 4725, auto crease borders. And we set up these 4 things here. These settings can give you slightly different results how it actually appear in the render. For me, I did a lot of tests. This is the optimal setup, but you can actually try whatever works best for you. You can do like 4 different maps with 4 different settings and combinations and see whatever works best for you. This is what I've chosen for me, right? So we just click create an export. We put it here, wherever it is, and it's baking. It's baking our map. One more thing I want to mention while it's baking the map is that after doing this, and because we are not using the plugin to export the maps, we'll have to go to Photoshop and flip the map vertically. And now it should ask if we want to export the model as well. Just to make sure that everything goes right, I say no here, and I go to regular export. I put the destination, model, OBJ, save. Okay, here we go. Now, as I said, we need to go to Photoshop and we want to flip our vector displacement map vertically. And if the plugin version is good for you and it works for you, great, just use whatever works better for you. I tried to put the settings flip vertically inside the ZBrush instead of doing this, and for some reason it shifts the vector displacement just a little bit, and the quality of vector displacement comes out lower. I don't know why that happens, I don't know how that works. So this workflow here is what I have found working the best for me. We save the file, and now let's go to Maya. Okay guys, Maya is up, so let's import the model. So first things first, we need to turn on Redshift as our render, and that's what I did. Now let's turn on our render window so we see all the updates in real time. And it says, yeah, there is no material. So let's create our material. We go to Redshift and we pick the Redshift standard material. You can pick wherever you want, but this material, this new material is, I just love how it works. It's probably one of the best things that Redshift ever had. So we select our model and we apply the material to it. Now I will do just a little bit of setup here to make it look a little bit more interesting. You don't have to do this at all, because obviously your model and your material setup will be very much different from mine. It's just, you know, I like things to look beautiful even on the setup process. Your work should look beautiful on any stage. So just a little bit of a subtle setup here, yet I think this is fine. First thing we need to do is to turn on the displacement and the tessellation for the Redshift model. So we select our model, and the same, you need to do the same for Cinema 4D and for any other software that you're using. So first thing, you turn on the displacement here. Very important. This thing will, if you forget to turn it off, it will give you a lot of headache later. So turn off this. Now, our model is obviously very low poly, and the vector displacement need to get those extra polygons somewhere to extrude the shapes, right? So we turn on the tessellation. This tessellation will happen only during the render time. So you have this on, no need to change anything for now here, but on this stage our model is ready to receive the vector displacement map. So we go to our hypershade and we find the shader, Redshift shader utility, Redshift displacement. We put it here. In the map encoding we put vector. In the space type we put tangent, and we pick the vector displacement file that we just created from Zbrush and that we flipped in Photoshop. The color space should always stay raw. This is important to remember as well. And I think we're all done. So this is the result of our work. And now, remember I told you about the tessellation that happens depending of how close the camera to the object is. So now we need to fix this. We select our model and we go to tessellation and minimum edge length. So before I change the settings here, I will show you what's going on. You see the model is on some distance from the camera here, and our details are kind of blurred, right? They are like smoothed out. So when I go closer to the model, our details here become much more obvious, right? Much more whole and visible. So this is because of the technology that I told you. So now to fix the problem where you want more details, on your selected camera distance, you go here and you change these two settings. So the lower you go here and the higher you go here, the finer your details will happen with your vector displacement map on the areas that are closer to camera. So this is why you don't need to have UDIMs to have very high quality renders, high quality models in your scene. So just by changing these two numbers, you can put 10 here, you can put 1 here, and now look at our model. Yes, it takes a little bit longer to render, obviously, but the quality, look at this quality here. Look at these details here. It's incredible. all our 80 millions of polygons are transferred right now to 79K model. This is insane. I think this technology is just absolutely insane. Look at the scales here on the wings. To me, this is magic. Like what is going on right now when I'm playing with this technology, with this vector displacement, this is pure magic, because how low poly the model is and the quality of the result we are having right now. Look at this. Isn't this insane? I think it is. I don't know why people are not using this technology more. I have no idea. So this is how easy you can set up vector displacement, and I showed you the process of creating it in Zbrush, and I showed you how to play with the quality of vector displacement. So now I would like to speak about troubleshooting some issues that you might have setting up the vector displacement. So issue number one is this thing here, enable auto bump mapping. You should always have it off, because on some stages of work it can kind of give you better results, right? It seems like this thing looks better, but if you come closer and you make more quality render, you'll see that it actually gives the artifacts on the where the geometry start intersect, and this intersecting bugs appear in the details of the model. So I'm always keeping this off. Now, another important thing is you should always keep your color space in the settings of the materials in RAW. Sometimes I upload the map and the default color space is sRGB or some other. And now it will change the whole picture, the whole vector displacement. It's like it's there, but it's not there. So you may think, what's going on? Why it's not working as it's supposed? This is why. Because your color space is sRGB, while it should be RAW. In not relating the package that you are working, Maya, Cinema 4D, Houdini, Blender, it should stay RAW. Another important thing to keep in mind is that the model scale that you are exported from Zbrush and that you created the maps from, like this one, has to fit exactly the same size of the model that you are having in your 3D software, Maya, Cinema 4D, or Houdini, or wherever. Because if you change the scale of your model, the scale of the vector displacement change, and you need to go here, right here, and adjust the scale. Let's say the model from Zbrush was 100, the size of the model is 100 centimeters, and you change it in Maya to 1 centimeter. That's where you need to adjust the scale and put this to the scale settings. So you need to remember that vector displacement scale is dependent of the scale of the model in your software and should stay relevant to the scale that you have in your Zbrush file. Now, the last thing that I wanted to touch base when speaking about the vector displacement is that when we are making the settings for the vector displacement export, and we have this number here, tangent flip, and depending on the software of your choice, this number here, this 25, it may be different. So how to find this number, how to define what number should you use in your workflow? You need to go here into the diagnostic here, you see, and you need to create diagnostic file. So this diagnostic file is basically the plane with the spheres on top, and the vector displacement is being applied to each of these spheres. And what you need to do, you need to see which sphere is the most accurate. It's this one, right? Number 25 in your selected 3D package. And then you need to put this number, 25 here. You need to put in your Zbrush settings right here. So if you're having problems how your vector map is displayed and you did everything right and you still are not getting the result you want, this is why it's probably might work wrong. I hope you guys got something useful from this tutorial. I really hope that more people will use this technology, because I think vector displacement technology is very much underrated. It gives a lot of freedom and a lot of new possibilities to artists, and I wish more people use it. Thank you for your time. Thank you for watching. I hope I was useful for you. See you later. Bye, guys.